In this video, we will talk about how to rotate a point around another point that is not the origin. So I have three examples for us to work through here. Let's check out the first one. Let's say we want to rotate the point 2, 5, 90 degrees clockwise about the point 1, 3. So here's the point 2, 5, and we're saying we want to rotate it 90 degrees clockwise around this point 1, 3. How can we do that? Well, here are the steps that we can use. The first step is we subtract the center of rotation. So the center of rotation is the point we're rotating around. We subtract this from the point 2, 5. So let's go ahead and do that first step. So we'll say the first step is we're going to subtract 1, 3 from 2, 5. So here's how we can write that. 2, 5 minus 1, 3. So 2 minus 1, that's 1. And 5 minus 3 is 2. So we get the point 1, 2. Okay, step 2 is we need to apply the correct rotation. So I've written a bunch of rules up here for what we need to do to actually apply the correct rotation. So remember in this one, we're rotating 90 degrees clockwise. So we can identify the rotation rule that we need to use right here. To rotate a point 90 degrees clockwise, we flip the x and the y, and we make the x have the opposite sign that it originally had. So let's do that. So let's say step 2 is this point 1, 2 is going to become, we flip the x and the y, so 2, 1, and we said the x needs, this value right here, the second value, needs to have the opposite sign that it originally had. So instead of a 1, we're going to write -1. Okay, and the very last step, step number 3, is we need to add back the center of rotation. So we have this point 2, -1, and we need to add back the center of rotation. Remember, the center of rotation, that's the point we're rotating around, so 1, 3. So we'll add 1, 3. So our final answer is 2 plus 1, that's 3, and -1 plus 3, that's 2. So 3, 2 is where our point will land. So let's plot that. So 3, 2. So basically what we said is when we rotated this point 2, 5 around the point 1, 3, 90 degrees, this is where we land at. And a neat way to check that you got the right answer when you're rotating 90 degrees is you can just draw a line from the point to the center of rotation, and then from the center of rotation to the new point, and just verify that it forms a 90-degree angle right there. And we can see that it does. So that's just a way to double check that, oh yeah, we must have gotten the right answer when we rotated this, because we have a perfect 90-degree angle to the final point where it landed at. All right, let's try another example. Let's say we want to rotate the point -1, 4, 180 degrees clockwise about the point 0, 2. So here's -1, 4. We're saying let's rotate this 180 degrees clockwise around this point 0, 2. Let's see where we land at. So remember, step 1, we have to subtract the center of rotation from the point. So we'll say step 1 is we need to do -1, 4 minus the center of rotation, which is 0, 2. So let's see what we get. -1 minus 0, that's still just a -1. And then 4 minus 2 is 2. So that's step 1. Step 2 is let's apply the rotation rule. So in this example, we're rotating 180 degrees clockwise. So let's find that rule up here. That would be right here. So it says the xy coordinates simply need to become -x, -y. So just flip the signs on both the x and the y. So we have -1, 2. We need to flip the signs on both the x and the y. So the -1 becomes a +1, and this 2 becomes a -2. And the very last step is add back the center of rotation. So we're at the point 1, -2, and we need to add back the center of rotation, which is 0, 2. So we'll say +0, 2. So our final answer is 1 plus 0, that's just 1, and -2 plus a +2, that's 0. So our final answer is 1, 0. So let's see what that looks like when we plot it. So that would be right here. So this is the point 1, 0. And what we'll notice is that basically what we did is we rotated it 180 degrees using this point as the origin. And what we can see is that if we draw a line once again from the point we started at to the center of rotation, and from the center of rotation to the final spot where it landed, we can see that this angle right here is 180 degrees. So that's just a way to verify that we got the correct answer. All right, let's try one last example. Let's say we want to rotate the point -2, -3, 270 degrees counterclockwise about the point 1, 1. So here's our point -2, -3, and we're saying let's rotate it 270 degrees counterclockwise using this point 1, 1 as our center of rotation. So let's see where we land out here. So step 1, subtract the center of rotation from the point. So once again, we'll start with our point, -2, -3, and we'll subtract the point of rotation, which is 1, 1. So let's see what we get. -2 minus 1 is -3. -3 minus 1 is -4. Okay, so step 2 is apply the correct rotation rule. So in this example, we're rotating 270 degrees counterclockwise. So we'll use this rule right here. It says the xy coordinates need to become y -x. So let's do that. So say we had -3, -4. We need to switch the x and the y. So -4, -3. And this second value right here needs to have the opposite sign that it originally had. So it was originally -3. This will actually become a +3. Okay, and the very last step is we just need to add back the center of rotation. So we have this point right here, -4, 3, and we need to add back the center of rotation, which is 1, 1. Remember that point we're rotating around. So 1, 1. So let's see what we get as our final answer. -4 plus 1, that's -3. And 3 plus 1 is a +4. So here is our final answer. This is where we land when we rotate 270 degrees counterclockwise. So if we plot that point, -3, 1, 2, 3, 1, 2, 3, 4. Let's label that -3, 4. This is where we land when we rotate this original point 270 degrees around the center of rotation 1, 1. And remember the trick that we used. If we draw a line from our original point to the center of rotation, and then from the center of rotation to the point where we land at, we should get an angle that is 270 degrees. So for this example, if we imagine that we form a circle like this all the way around, that would be 360 degrees. And we can see that this right angle is 90 degrees. So that means this angle right here must be 360 minus 90, which is 270. So that's just a way to verify that we got the correct answer.